Hey, grade nines. So we are now on our last lesson here. Of the unit. So we're going over simplifying polynomial expressions. So this lesson should be pretty easy. There's not really much to go through. Just want to basically put together everything we've done in the unit so far. Basically at the beginning of the unit, we talked about key terms, and I just wanted to make sure you knew exactly what they meant. So we talked about what the definition of a like term is, what a variable is, coefficient, and then we have gradually moved on to multiplying powers, and then we got into adding and subtracting polynomials. And finally, what we did in the last lesson was multiply a monomial by a polynomial inside. So now we're just kind of talking about simplifying overall, right? So putting all these rules together. So generally what you want to do first, if you have this, you want to expand any brackets by multiplying the monomial by the polynomial inside the brackets. And that means that we're going to be using distributive property. So that's what we did in the last lesson. So we're simply going to take the monomial here inside the bracket and multiply by the polynomial, by each of the terms in the polynomial inside. And then what we do after that is we apply exponent laws. If you're multiplying the powers with the same base, that's a key word there. If they have the same base, if they don't have the same base, then you actually can't really apply exponent laws. You simply put the variables next to each other. There's not really much you can do there. And finally, you collect up the like terms. So once you've actually distributed and you simplified the terms, you look for any terms that have the same variable and same exponent. And if they have the same variable and same exponent, we simply add or subtract. We simply add or subtract the like terms, and we do that by adding the coefficients that are in front. So hopefully that kind of makes sense. So let's look at some examples here. So expand and simplify this expression. So now we're just basically seeing that we're kind of doing what we did in the last lesson, except that we're doing it twice or 3 times, right? We're just doing it a couple more times. So if we are expanding and simplifying this expression, first you want to multiply the monomial outside by the polynomial inside, and we're going to do it on both cases. So it's almost like we have two separate questions. I have to do it for 2 multiplied by y to the power 3 minus 4 y squared, and then I have to do it for -3 multiplied by y squared and -3 multiplied by -4y to the power 4. So I almost have two different products that I'm working on. I'm working on this one here, and I'm working on the first product here as well, okay? And again, the sign in front is extremely important. Notice that I cannot skip that negative sign in front of the 3. That actually makes a huge difference, so you want to really watch out for that. So what we're going to do is, and this looks like Christmas colors here. So we are simply going to take our 2 right here in the first, in the 2 in the first expression, in the first product, and multiply by the polynomial that is inside. So we take 2 multiplied by y to the power 3, and then we take 2 multiplied by -4y squared. And that's exactly what I'm doing here. So I'm going to end up with 2 different products that I have within the first within the first part of the expression, I'm going to end up with 2 different products. So 2 multiplied by y cubed and 2 multiplied by -4y squared. And then for my next part of the expression, I'm going to take -3 and I'm going to multiply by 4y squared. And then I'm going to take -3 and I'm going to multiply by -4y to the power of 4. And it's going through all these steps, just making sure we're kind of following so far. All we're going to do is simplify these 4 expressions. Now, I think what gets really confusing is just the fact that there are negative signs throughout the expression. And I think it's human nature that we tend to always want to subtract right away. But remember, this is just going back to basics. We always, always, always multiply before we subtract, right? And this just goes back to what you did in elementary school, right? Bad math. You always want to multiply before you, want to multiply before you subtract or add. So that means that we are not going to do anything else until we first multiply the terms together and simplify them. So we're going to have to simplify these 4 terms first, okay? So that's our first step, is to simplify them. And then we'll worry about adding and subtracting, right? And again, we either add or subtract just based on the sign of the product. So in the next step here, we have 2 times y cubed. 2 times y cubed gives me 2y cubed That's pretty easy. And then I have 2 times -4. 2 times -4 is -8. And we have a y squared there, so we just have -8y squared. Then I have -3 multiplied by y squared. That's also quite easy as well. -3 times y squared is -3y squared. And finally, we have -3 multiplied by negative y to the power of 4. And the -3 is multiplied by that. Technically, there's an imaginary -1. We just don't see it. -3 is multiplied by -1. And that ends up giving me a positive. So you might want to just watch out for that because the sign will switch. So it's going to be multiplied by the positive. It's going to be -3 times -1 gives me +3. So I make sure I put a positive. I make sure I add 3y to the power of 4, right? And finally, now once I know what the signs are and what the products are, I always ask myself, can I go any further? So this is what's new about this lesson compared to the last one. In the last lesson, we noticed that there weren't normally like terms once we distributed. Now we're going to be distributing, and at the very end, we're also going to have like terms. So we're almost mixing in all the different rules we learned. So we notice here that we're actually not done yet. You can go further because there are like terms. And my two like terms, hopefully you can see it here, and I'm just going to highlight it, is going to be -8y squared and -3y squared. So because those are my two like terms, I can simply add them up, and that becomes -11y squared. And again, to add up like terms, I just simply add the coefficients in front. So I add -8 and -3. So -8 plus -3 gives me -11. And that's why I ended up with -11y squared. So I hope that makes sense so far. So general rule here, just kind of going over some standard protocol we have with whenever we're simplifying, expanding, simplifying. You always want to write the expressions in descending order. So that normally means that you want to write the highest degree first, and then you want to go all the way down. So in this case, this is fine if I write this as an answer, but it looks much better. And of course, when we talk about standard notation in math, that's just kind of following a normal protocol that most mathematicians agree on. We want to write the 3y to the power of 4 first, because that actually has the highest exponent there, or the highest degree. And then we have 2y to the power of 3. That's going to be next, because that has the second highest degree. And then, of course, we have -11y squared, which has the lowest degree there. So we put that at the very end there. So it's really customary that we start with the highest and then go to the lowest degree term there. Let's look at another example here. So we have -y and then in brackets multiplied by y squared plus 5y minus 4, and then plus 3y multiplied by 2y squared minus 5 minus y plus 6. So again, going through the steps here, we're going to have negative y multiplied by y squared. So we're just simply going to take the monomial in the at the very beginning here of the expression, and what we're going to multiply by every single term that is in the polynomial in the set of brackets there. So we're going to take -y and we're going to multiply by y squared, and then take -y multiplied by 5y and -y multiplied by -4. So this looks a little bit messy, but I'm hoping everyone kind of sees where this is coming from. So I'm taking -y multiplied by y squared, and I'm going to switch back to the pen here. It's just a little easier to read. And then I take -y multiplied by 5y, which is the next term in the polynomial. And then I'm going to take -y and I'm going to multiply by -4, which is the last term in the polynomial there. And then once I'm done with that, I'm going to go to my next set of terms that I'm multiplying. So I'm going to take the -3, the next polynomial, and I'm going to multiply by the first term in the polynomials in the brackets. So I'm going to take 3y and I'm going to multiply by 2y squared. And then I'm going to take 3y and I'm going to multiply by -y. And that gives me this expression right here with the sign, really important. Make sure you include the sign there. And then, of course, I have 3y multiplied by 6 at the very end there. So I'm simply going to take 3y and multiply by 6. Notice here, I'm not as particular about including the positive sign, and it's because normally when you multiply by positive numbers, that's not really the issue, right? When you multiply by a positive number, the sign doesn't change, so I don't have to worry about it as much. But in that first one, I really emphasize that there's a negative there because it will change the sign of the term, right? So just really keep that in mind. So just missed some inconsistency here. Want to put the little arrow there to show that the 3y is multiplied by 6, so I didn't miss it there. Okay, so and our next step is I'm simply going to just, I'm going to simplify each of the products that I have here. So I have negative y times y squared. So if I have an imaginary exponent 1, I think that makes a little more sense. So I have negative y times y squared. That ends up giving me negative y cubed. And then I have for the next product, negative y times 5y. A negative times a positive is a negative, so then I make sure I put a negative there in front. And I have 5 in front, and it's the only number, it's multiplied by 1. So nothing happens there. And then I have y times y, which is y squared. And the third product here, I have negative, a negative times a negative. We know a negative times a negative is a positive. So I'm going to be adding that product. And I have 4 times y, which is 4y. So that's pretty easy as well. And then I get to my fourth expression, sorry, my fourth term, which is linked to the second half of the expression there. So I'm going to take 3y times 2y squared. So 3 times 2 gives me 6. And I know that y times y squared is 6y cubed. And then I have 3y multiplied by negative y. I know that 3 times negative 1 is negative 3. So I just make sure I subtract it because I have a negative answer. So that means I'm going to be subtracting the term. And then y times y is y squared. And finally, I have 3y multiplied by 6, which is the very last step here. And 3y multiplied by 6 gives me 18y. So piecing this all together, I look at this and I realize, okay, everything's been simplified. All the terms are definitely simplified. So what's my next step here? Well, my next step is to go one step further and simply collect up the like terms. So adding up my like terms, I noticed that, and it's probably going to be helpful to highlight in this case. I will highlight all the like terms here. So I noticed that negative y cubed and positive 6y cubed are like terms. And notice that I just look at the sign in front to tell whether you add or subtract. Negative 5y squared is going to be the like term with negative 3y squared. And finally, let's just get a different color here. I have 4y, which is going to be like terms with 18y. So that means I'm going to add up the ones that have, we're going to add up the like terms, or the ones with the same color in this case. So when we add them up, again, we can probably move them around next to each other, so it's a little easier to add. So I simply put negative 3y cubed next to 6y cubed. And we're going to notice in this case, and I'm just going to go back to having a pen here, that all we're really doing is we're simply adding up the coefficients for the like terms. So here we have an imaginary negative 1. You want to picture a negative 1 plus 6. So an imaginary negative 1 plus 6 is going to give us positive 5. Then we have negative 5y squared minus 3y squared. That's going to give us negative 8. And the last one here is going to be pretty easy. 4y plus 18y is going to be 22y. So we end up with, and again, I'm showing all the steps here of how we're actually finding the coefficient here. So we have negative 1 plus 6 is going to give us 5. Negative 5 minus 3 is going to give us negative 8. And by the way, the only reason I'm adding that plus sign, if you're wondering, like, why did you put the plus sign there? It's because we know that really, and I've talked about this already, it's probably easier to always think of adding terms. And the only difference is that we are sometimes adding a negative term, right? And that's exactly what's happening in this case. We're adding a coefficient because, we're adding a negative term because we have negative 5 minus 3, which ends up giving us a negative answer. So we can either think of it as adding the negative 8 or subtracting adding the negative 8y squared, or as subtracting 8y squared. It gives us the exact same answer in the end, right? So this shouldn't hopefully throw you off too much. I just basically am showing you how I am finding the coefficient when I add up the like terms there. And this is my final expression. I end up with 5y cubed minus 8y squared plus 22y. So all I had to do at the end there is just add up any like terms. A couple more examples that are a bit more complex. So let's look at this one here. So we have 3m cubed multiplied by 2m squared minus 5m plus 3 minus 4m multiplied by m to the power 4 plus 2m cubed minus m squared. These are just a bit hard to always say. So now we end up in this next expression here. We end up just multiplying 3m cubed multiplied by 2m squared. So 3m cubed multiplied by 2m squared is going to end up giving us this expression right here. And then we have 3m cubed multiplied by negative 5m, which means we're going to be multiplying these two terms here. And then we have 3m cubed multiplied by 3m, which means we're going to be multiplying these terms here. And of course, for our next part of the expression, we're going to take the monomial negative 4m, and we're simply going to multiply by the terms in the polynomial. So we're going to take negative 4m, and we're going to multiply by m to the power of 4. And then we're going to take negative 4m, and we're going to multiply by 2m to the power of 3. And finally, we're going to take negative 4m, we're going to multiply by negative m to the power of, negative m squared. So going step by step here, we are simply going to, simplify each of these products here. So 3m cubed multiplied by 2m squared is going to give us 6m to the power of 5. 3m cubed multiplied by negative 5m is going to give us negative 15m to the power of 4. And 3m cubed multiplied by 3 is going to give us 9m to the power of 3. And our next part, we continue on. We have negative 4m multiplied by m to the power of 4 gives us negative 4m to the power of 5. And then we have negative 4m multiplied by 2m to the power of 3. So I'm on the second last one here. Negative 4m multiplied by 2m to the power of 3 is going to give us negative 8m to the power of 4. And finally, we have negative 4m multiplied by negative 8m squared. So we have a negative times a negative, which gives us positive. So we have positive 4m to the power of 3. So just double check that all the math is correct. I could always make a mistake, but it's looking like it's fine here. I think we simplified all the powers. And again, just so you're clear, I started to skip a couple steps here, and I hope you know where I'm getting the different, how I simplified this. All I really did was multiply the coefficients together. And then of course, with the powers, whenever the powers have the same base, in this case, that's what happened here. We have m cubed times m squared. I simply add the two exponents. So I'm not showing these steps anymore, but I hope you understand where I'm getting that exponent 5 from, right? I'm simply adding up the exponents because I'm multiplying powers. And same with the next one, I have 3m to the power 3 multiplied by negative 5m. There's an imaginary negative one, imaginary exponent of 1. So I'm simply taking 3 plus 1, which gives me 4. And that's how I ended up with negative 15m to the power 4. So I hope you understand where I'm getting all the numbers, all the coefficients and the exponents from. And then finally, I simply add up any like terms. So I look here really carefully. There are a couple like terms, and I actually have decided to just place them next to each other just to make it easier. So I have 6m to the power of 5, which is obviously going to be like terms with, let me get the highlighter here. 6m to the power of 5 is going to be like terms with negative 4m to the power of 5. And so I just simply put them next to each other. Then I have negative 15m to the power of 4, which is like terms with negative 8m to the power of 4. So I also put them next to each other. And notice that when I move them next to each other, I always look at the sign in front when I move them around, right? So you don't ignore the negative sign. You have to move the negative sign in front as well. And then finally, we have the very last one here, which is 9m to the power of 3, which is like terms with 4m to the power of 3, and I simply put them next to each other as well. Notice that if I didn't actually move it, but if I ever move the first term and you notice that the first term is positive, or there is no sign, actually you just notice that there's no sign at all, don't forget that that first term is automatically positive, right? So we tend to not put a sign at the very beginning of the expressions, but it's kind of implied that this first term is positive, right? We just don't actually say it. So just make sure that you keep that in mind if you ever have to move that first term around, and it's positive there. So all we have to do in this case is add up the like terms. So we add or subtract the coefficients in front. So we have 6m to the power 5 minus 4m to the power 5, which gives us 2m to the power 5. Negative 15 minus 8, do the math there, is negative 13, and sorry, negative 23. So we end up with negative 23m to the power 4, or we subtract 23m to the power 4. Really, that's the same thing. And then, of course, we have 9m cubed plus 4m cubed, which is 13m cubed. And that's it. And just a reminder here, when you add like terms, you do not change the actual exponents themselves, right? And we don't change the variable at all. We just add or subtract the coefficients. Let's look at one more example here. So we have 15 minus 2, and then in brackets, a squared minus 5. So this one is the one that tends to, it seems really easy. It's actually not long at all, but it's confusing because I think it's human tendency to want to, again, do the operations that seem the most visible. And in this case, I think most of us can agree, for some reason, this 15 minus 2 seems like the first thing that we should do, right? It just seems extremely visible. It, for some reason, right? Just because you see it right at the beginning, and it's kind of tempting you to want to subtract first. But just so we're clear, that's not what we're going to be doing, right? And this all goes back to what we learned in elementary school, right? BEDMAS. We always follow the order operations. So following the order operations, this means that we're going to need to multiply or expand the monomial 2 before we even subtract from 15. So you want to do this step of multiplying the 2, and actually specifically the negative 2, and I should probably change that, the negative 2 by a squared and by negative 5. I want to do that first before I subtract anything from 15. So there are two different ways I could do this. I could think of it as, and I know some of you might be asking already, why couldn't you just consider the 2 without the negative sign and then just subtract it off? You could do it that way as well. You could actually do 2 multiplied by a squared and then 2 multiplied by negative 5, and then take that answer and subtract it from 15. But that would actually mean that you're subtracting a polynomial, which means you have to switch all the signs. That actually, I feel like personally that gets a bit more confusing. I rather actually just multiply by negative 2 to begin with, and then just add that on to 15, right? That would give me the exact same answer anyways. So I'm actually going to do it that way, if that's okay with you guys. I'm going to take negative 2, and I'm simply going to multiply by a squared, and then I'm going to take negative 2, and I'm simply going to multiply by negative 5. So negative 2 multiplied by a squared, we're going to figure out what that expression gives, what that simplifies to, and then I'm going to take negative 2 multiplied by negative 5, and that's this next part there. So going step by step here, I have 15 minus negative 2 times a squared, and negative 2 times a squared is negative 2a squared, and then I have negative 2 times negative 5, negative 2 times negative 5 is positive 10. So now my next step here, I look at this expression and I am almost done. I just have to add up the like terms. So the like terms are 15 and 20, sorry, 15 and 10, and obviously 15 plus 10, and we just add because there's a positive sign in front, gives us 20, sorry, 25, and of course I would put the negative 2a squared in front because you, it actually has a higher, like I said, when we're simplifying our expression and we're adding or subtracting polynomials, you normally are adding subtracting terms. Sorry, that's what I meant to say. You normally want to put them in descending order. We talked about that. So you put the highest degree at the very beginning, and of course constants by themselves are always going to go at the end because technically they do have an exponent, but the exponent is 0, right? So you normally want to put the constants by themselves at the very end there. And when we're multiplying, obviously that's different, right? We put the coefficient, the number in front. But in this case, I leave it as negative 2a squared plus 25. And then that's my final expression there. And we just have a word problem now. So the word problem here, finding an expression if you're given a problem. And hopefully this won't be too difficult. We've actually done a couple examples that are similar to this. The only difference now is that we're just combining a couple different expressions now. So let's say that you're making fabric pieces for an art project and they can be cut into 2 different sizes. So you want to find the simplified expression for the area of the fabric needed if 14 students choose the large one, which is shown right here in blue, x plus 10 multiplied by x. And if 12 students choose the smaller one, which is x plus 5 by x. So what we're going to do in this case is simply write an expression for the larger piece, for the area of the larger piece. So we're simply going to take length times width. So in this case, our length is x plus 10, and our width is x. So that's quite easy. We're simply going to multiply it together. We end up with x times x plus 10, which gives us x squared plus 10x. By the way, you'll probably note here that I changed it a little bit. I have length times width, and then I actually put the width first and then the length. Again, order doesn't matter when you multiply, as long as, like I said, it's customary once you get your final answer to put it in descending order. But really, I could have multiplied it a different way, right? I would have gotten the same answer if I did x plus 10 multiplied by x. I get the exact same answer if I do that, okay? So I end up with x squared plus 10x. And I'm going through this a little bit faster because I think most of you are kind of getting this. It's not too difficult. And we're just going to piece it all together in the end. So then we end up with x multiplied by x plus 5 to find the area of the smaller size. And this ends up giving us x squared plus 5x. Now, finally, when it asks for a simplified expression for the area, the total area needed, for if 14 students choose a larger one and 12 students choose a smaller one, all we're going to do is take our previous answers here and multiply it by the number of students that are receiving each piece. So that means that we're going to have, and I put total cost, I meant total area. I'm going to change that there. So we're going to take 14 and we're going to multiply by the whole entire expression for area for the larger size. And then we're going to take 12 and we're going to multiply by the expression for the area of the smaller one, right? And that's all we're doing here. And really, we're just using distributive properties. So we're taking 14 multiplied by x squared plus 10x, and then we're taking 12 multiplied by the area of the smaller one, which was x squared plus 5x. And I made a mistake there, 5x. So then you distribute this out, you end up with 14x squared plus 140x plus 12x squared plus 60x. And of course, in my last step here, and I hope I actually simplified this, I can't remember if I did, we end up with 26, and I made a couple mistakes here. This was done a little bit late at night, so there definitely could be some errors here. We have 140x, so we add up the like terms, so we have 14x squared plus 12x, which gives us 26x squared. And then we have 140x plus 60x, which gives us 200x. And there is our final answer. And that's all we had to do in that case. So I hope that kind of made sense. And I apologize for the couple of errors there, but as you can see here, the pretty easy to fix. So all we're doing here is just basically combining all the different rules that we've learned so far. And that is it for the lesson. And there are the questions. Again, a reminder that your test on Unit 2 is on Monday, and the first part of the culminating tasks will take place on Tuesday next week, so right after the test. All right, best of luck.